Pascal's triangle. So the way that we make Pascal's triangle is that we start with a 1 on the top of the triangle, and we always have 1s on the outside of the triangle. So this will be a 1, this will be a 1, this will be a 1 here and a 1 here. So there's always 1s on the outside. And to get the other numbers, we add together the 2 that are above. So 1 and 1 is 2. Okay, so the next row will be 1, 1 and 2 is 3, 2 and 1 is 3, and 1 on the end, and so on. So that you can see the next one will be 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, and 1. Okay, so you're just adding the 2 above to get the 1s below. Now the reason we need this is because these numbers inside Pascal's triangle have a special meaning, and we're going to use those when we do the binomial expansions. So first of all, we need to look at the notation that we're going to use for this. Now first of all, what we're going to have to do here is the top row of Pascal's triangle we're actually going to call row 0. See why in a minute, it just makes the formula work out easier. This is going to be row 1, and then the next row will be row 2, row 3, and so on. Okay. Now, if we take the top row 0, so this number in the Pascal's triangle we're going to get from the calculator, and we're going to do it using a special function called combinations or choose. Now it's going to be, this one will be 0, choose 0. Now I'll explain more in a minute. I just want to fill in the numbers and how we get them first of all. So 0, choose 0. Now in the first row we're going to have 1, choose 0, 1, choose 1. Okay, just concentrate on how I'm making the letters here first of all, and then we'll explain afterwards. Second row, it's 2, choose 0, 2, choose 1, and 2, choose 2. Okay, third row, 3, choose 0, 3, choose 1, 3, choose 2, 3, choose 3. Okay, we'll just do one more. 4, choose 0, 4, choose 1, 4, choose 2, 4, choose 3, and 4, choose 4. Okay. Now, you can see that the row number obviously is the number on the top of this thing we're using, and the numbers on the bottom obviously just start at 0 and go up by 1 to the end. So in the fifth row, obviously you'll be 5s on the top like this. Okay, and then this will be 5, choose 0, 5, choose 1, 5, choose 2, 5, choose 3, 5, choose 4, and 5, choose 5. So the last number, obviously, the last one on the row has to be the same, like 5, choose 5, this is 4, choose 4, 3, choose 3. Okay, now before I explain what these numbers can actually mean, I want to show you how we can get these from the calculator. So, just bring up the calculator. Okay, get rid of that. Okay, so on the calculator has a function for working out these numbers. Okay, so you can either use the math menu, so you go math, go across to probability, and you can see we have one. The third one here is n choose r. Okay, so I'll just try that. So let's say we wanted to create work out what this number is in the Pascal's triangle. Yeah, 4, choose 2. Then what we're going to do is just put a 4 here and a 2 here. So 4, choose 2 is 6, and you can see that that's corresponding to this number in the Pascal's triangle. Yeah, 4, choose 2 is 6. There's another way to do that. Same thing is you can even type the 4 first if you want and then do the function. It'll automatically insert it. But anyway, so instead of going to the math menu, what we can do is alpha F2 Yeah, these green menus have kind of shortcuts to some of the useful functions, and then go down to number 9. You can actually just type 9 and it'll automatically, sorry, not number 9, sorry, alpha F2 number 8. Yeah, and then just fill it in again, 4 and 2. Okay, so you can see it's easy to generate these numbers in Pascal's triangle using this choose function. And the only tricky thing is that you have to, it's always kind of 0 going in kind of in this diagonal, yeah. The first one in the sequence here has to have a 0 on the bottom. Okay, another thing that they want you to know how to do is actually how to generate the whole row. Okay, now we can do that quite easily. You go to y equals. Now I'm going to go and put in a choose function. So I'm going to go to F2 again, because it seems easier, and number 8. Okay, so we've got the choose function there. Now, if I want it to display in a list all of the whole row of a Pascal's triangle, so let's say I want to do the 5th row. Okay, so what I'm going to do is I'm going to put a 5 here because I want the 5th row. And normally we would put a number here, say I want 5 choose 3 or 5 choose 2 or whatever. But if I want to generate all of them, I'm going to put an X here, because then the calculator will automatically put all the numbers in and work them out and put them in the table. Okay, so I've got 5 choose X. So if I now go to my table, so second table, you can see I've got the numbers here. Now notice for negative numbers, it doesn't know what to do with that, so it gets an error. And so you can see the 0, 5 choose 0 is 1, 5 choose 1 is 5, 2 is 10, and so on. So it's giving us the numbers from the the 5th row. Yeah. Obviously, if you wanted the next row, the 6th row, you would just have to go and change this to a 6, enter, go back to the table, and it's giving you the 6th row here of Pascal's triangle, and we need to know how to get that for when we do the binomial distribution. Now, just to show you one application of this, these numbers in Pascal's triangle can be used for finding combinations. Okay, so for example, so for example, imagine you've got 5 people, A, B, C, D, and E. So 5 people, and you're going to make a team of 3 people. Okay, how many teams can you make? Okay, so you've got 5 people to choose from, and you need you need 3 people in the team. So obviously we could have A, B, and C in a team. We could have A, B, and D in a team. We could have A, B, and E in a team. Yeah. We could have A, C, D, A, C, E, or A, D, E. They're in a team. Yeah. Obviously, if we chose C and B and A, that's still the same team of people. Yeah. So so this is all the teams that have an A in them, aren't they? So we could also have B. We could have B, C, D. We could have B, C, and E as a team. What else? We could have B, D, E. Yeah. I think that's everything with the B's that are not already mentioned before. And then, of course, we could have C, D, and E in a team. Yeah. So you can see there's 1, 2, 3, 4, 5, 6, 3, 1, 10 in a team. In fact, you can see there's 6 here, 3 and 1, which these numbers are actually coming up in the Pascal's triangle also, aren't they actually? So anyway, there's 10 teams, and this signifies that if you have 5 people choose 3, it means how many teams of 3 can you make from a group of 5 people? Yeah, and there's lots of situations where we have to do this in maths. You don't need it for this course, but that's one particular application of it. And again, it's kind of linked to the binomial situation as well, which I'll show you later. But at the moment, we just need to know how to generate these numbers, and then we're going to use them later. Okay, now I'll just get rid of this. Sometimes we need to generate the numbers by hand, so I just want to show you that, and also show you where the formula comes from, because there is a formula in the formula booklet which you can also use instead of using the calculator or Pascal's triangle. Okay, so let's say it was a paper 1 and you have to find 6, choose 2. Oh, let's do a harder one actually. Let's say you had to do 10, choose 2. Okay. Now, of course, what you could do is extend the Pascal's triangle until you get to the 10th row. Yeah, so that's one possibility. Obviously, you can use the paper 2, you can use a calculator, but if it's paper 1, you wouldn't be able to. So here's a method. So what you can do is basically imagine a fraction with a 10 on the top and a 2 on the bottom. Okay, now on the bottom, I want you to imagine that we're going down in numbers from 2 to 1. So 2, and multiplying them together, so 2 times 1 basically, yeah? And on the top, because we have 2 numbers on the bottom, yeah, because this number is a 2, we need 2 numbers on the top, so I'm going down by 1 each time, so 10 times 9, yeah? So this is how, this is will give you the correct result, okay? It's just a shorthand way of doing it. So 10, well actually we can cancel this down, yeah? And you can see it's going to be 45, yeah? And if we check that on the calculator, we'll see that it works. So 10, choose 2, yeah, 45. Okay, let's do another one. Let's say we had 9, choose 3. Okay, so again, like I'm saying, because there's 3 on the bottom, there has to be 3 numbers basically multiplied together on the bottom, and there's going to have to be 3 numbers multiplied together on the top. Okay, so on the bottom you're going to have 3 times 2 times 1. Yeah, it always just goes down by 1 until you get to 1. On the top we're going to have 9, yeah, times 8 times 7. Okay, so you're going to have to work out this. Now, although it looks like it's going to be complicated, it's actually quite easy because you can just cancel things down. So divide the top and bottom by 3, that'll be 3. This 2 we can cancel with the 8, so that's 4. Okay, so we've kind of made it easier for ourselves. So now we've got 3 times 4 times 7. Yeah, you can do those in any order you want. So either do 3 times 4 is 12, 12 times 7. Or you can do 3 times 7 is 21, and then times by 4. But anyway, it's 84, isn't it? Yeah. Okay, so we'll do a bit of practice of finding those by hand later, but you can see it's reasonably straightforward to do it by hand. Now, just a point about the Pascal's triangle. One of the things that we notice about it is that it's symmetrical. So you can see it's the same numbers coming in from each side. So for example here, 5 choose 0, obviously that is the same as 5 choose 5, isn't it? And 5 choose 1 is the same as 5 choose 4. We can see that here, yeah? They're both 5. And 5 choose 2 is the same as 5 choose 3. Now that symmetry can be used if you get something a little bit more complicated. So for example, if I was asked for 9 choose 6. Now 9 choose 6, we could actually write it like 6 times 5 times 4 times 3 times 2 times 1. Then we need 6 numbers on the top, so 9 times 8 times 7, 6 times 5 times 4. But can you see that that's going to take us a long time to either multiply or cancel it out, because the numbers are going to get pretty big. But what we can notice is that if we have 9 choose 6, by symmetry, can you see that actually it's the same as 9 choose 3? Yeah? If you go 3, you're basically going in from 3 from each side. So you're going to have the same number. If these two numbers, you can see, add up to 9, yeah, add up to the top number, then it has to be the same result. Yeah? So instead of doing 9 choose 6, it's easier to do 9 choose 3, and we've already done that. It's 84. Yeah? So let's just do another one of that. So if I said to you, what's 10 choose 7? Okay, well what you would do is you'd say to yourself, well, instead of doing 10 choose 7, from symmetry, I'm going to do 10 choose 3 because it's much easier to calculate. Yeah, so then I would have on the bottom, we would have 3 times 2 times 1, 3 numbers on the bottom and 3 numbers on the top. Okay, and then of course we can kind of start cancelling down if we want to. So that'd be 3, and this would be a 4. So 10 times 3 times 4, it will be 120, and you can check that on the calculator. Okay, right, the final thing is, oh sorry, let's just do this example here actually. It says find R when 10 choose R is 210 using a table of values generated with technology. So we have to solve this equation. 10 choose something is going to be 210. Okay, so what we can do is use the calculator to basically work out the 10th row of Pascal's triangle. One of the numbers in the 10th row of Pascal's triangle will be 210. And we basically need to work out which one it is. So go to here. So instead before we had 6 choose X, we're going to change that to 10 choose X so we can generate the 10th row of Pascal's triangle. So go to the table. Here's my table, and you can see 210. Can you see it's 4? Yeah, 10 choose 4 is giving you 210, but can you see actually there is another solution because of the symmetry. 10 choose 6 is also 210 from what we were saying. So in this case, R equals 4 or R equals 6. Yeah, obviously these two solutions have to add up to 10 from what we said about the symmetry. Okay, one last thing, I just want to talk about the formula for this, for the combinations, and that involves using factorials. So for the factorial, basically the notation is if you have 4 factorial, what it means is 4 times 3 times 2 times 1. Yeah? So 4 times 3 is 12 times 2, that will be 24. Yeah? Now obviously if you have something like 10 factorial, it will be 10 times 9 times 8 times 7 times 6 times 5, 4 times 3 times 2 times 1. Okay, now that's going to take you a long time to calculate it. Yeah? So obviously on the calculator there is a shortcut. I don't think they're going to expect you to do would expect you to do something like that by hand. Obviously, it would be too much. So so on the calculator again, we just type in 10, and to get factorial, you can either go again to the math menu or use these shortcut menus. So alpha F2 and use number 9. So 10 factorial. It's this this big number here. Okay, so it's easy to find factorials. Now, how are we going to use this to find a formula? Well, if I go back to what we were doing with these numbers, yeah, let's okay, let's do this one actually. Hang on, I'll just change the color here. Okay, so 9 choose 6. Can we see how that is formed and then see if we can work out what the formula is? Now, can you see that on the top we have 9 times, well, let's do the bottom first, which is easy. The bottom is 6 times 5 times 4 times 3 times 2 times 1. That's obviously just 6 factorial, isn't it? Okay, so that's easy. Now on the top, it looks as though it's close to 9 factorial, isn't it? Yeah. The problem is, if we had 9 factorial, we would have all the numbers. Yeah. This is 9 factorial, isn't it? Yeah. Obviously, in our formula here, we only want to go down to 4. We want to take off basically this 3, 2, 1 on the end. We want to take it off there, so we need it to cancel out. So can you see that we can put 9 factorial on the bottom, but if we want it so that it on the top we only get it down to 4, we need to put a 3 factorial on the bottom. Yeah? Can you see that makes sense? Because if I have 9 factorial on the top and then 6 factorial, and then obviously times by this 3 factorial, 3, 2, 2, 1. Obviously this will just cancel, yeah, this will all just cancel with this, and I'll be left with what I want. Okay, so that's how we can make the formula that we need. Now obviously we have 9 choose 6 here. Our formula has n choose r in it. Okay, the formula in the formula booklet. So on the top, you can see we're just going to have the factorial of the, before it was 9, now it's going to be n. So it'll be n factorial over the number on the bottom, the 6 factorial, so that was the r factorial. But we need to get this 3 factorial thing. And this 3 factorial, basically, if you think about it, was just the 9 take away 6. Yeah, so that you make off, you basically want the 6 numbers and the rest of them, the first 6 numbers, yeah, 9, 8, 7, 6, 5, 4, that's 6 numbers, and then the other 3 to cancel. So it's just the 9 take away 6, which if we have n and r, will be n minus r factorial. Yeah, so the formula looks really complicated actually, but it's when you think of it like this, it's you can see the reason why. So if you're using the formula, so let's say you were asked to find, I don't know, 12 choose 5 or something. Okay, in using the formula, obviously it's much easier to use the built-in function, but you need to be aware of this formula. You would have to do 12 factorial over 5 factorial times, well, 12 take away 5 is 7 factorial. And if you work that out and check it, you'll see it's exactly the same as 12 choose 5. Okay, so just to recap, go back here. We're interested in the Pascals triangle, yeah, which is linked to these choose numbers. And hopefully you can see how they're generated. And we can either get them from these numbers from the calculator, or we can use the formula, or we can do it by hand.